All right, all right, all right, all right. How is it going? How is it going, you fine people? You fine people! What's good? What is good? What is good? What is good? How you doing? Thank you for dropping by. Thank you for hitting that play button. Let's go. I appreciate you. Johnny with Bologna&Weiners coding. Let's go. Let's go. Getting you guys and gals all pumped up and excited. Is it working? Is it working? I don't know. Probably not. All right, turn it up, turn it up. You guys know I appreciate you dropping by, stopping by, showing up, growing up. Let's go. I love it. I love it. Appreciate you. Just gotta finish with this mod stuff. Yeah. Get it done and out of the way so I can focus. Guys, gals, lurkers, twerkers, and sandwich making workers, much love. Thank you for stopping by. Let you guys and gals get settled in. Make sure you have your drink and your liquids and your note-taking stuff, and whether you're using an application or old school, no school like old school. No, what I mean is like pencil, paper, whatever you want to do. Again, it's great to have you. Getting close to being done here. Dropping stuff here in the live stream because, If you're watching this when it's not live, this used to be live. Sometimes I kill myself. Not physically, literally. Literally or is it figuratively? Who cares? Doesn't matter. All right. Yes. Let's finish up. Some positive quotes. Positive quotes for you guys and gals in chat to keep you motivated. You know. Hopefully it's gonna help keep you motivated. Again, this is C++ that we're doing over here, guys and gals. It is a lecture, just to be clear. It is a lecture class we're doing here. Free online course, lecture. We're following a guide. Turn it up. So we kind of have a plan, a little bit of a plan. Whether I'm following the plan, that's another story. I'm trying. All right, I think that's it for this. Be closed. All right, because you're a distraction. I must get that out of the way so I'm not distracted so much. Check the stream for this. Let's go. All right, poppin' saucin' poppin'. All right, I just came up with that. Hopefully I remember to use it in the future. Poppin' saucin'. All right, guys, gals, that's enough. You guys know. I say it way too much, probably. But yeah, supporters, followers, lurkers, and twerkers, those that hit the play button, you guys are all great. I appreciate you, okay? You know I do. We're going to get right into this. Doing my best to shorten these intros. I'm working on it, guys. I'm working on it. My content, obviously I'm on Twitch streaming this, right? It's great to have you guys. Thank you, Twitch, for sharing the content. Appreciate you. There's some people that are actually finding the content because you're sharing. It's amazing. I love it, actually. And they're hitting the old follow and play button or whatever while they're playing, and then they're following, right? It's amazing. I love it. Thank you, guys. Thank you so much. Eventually I move, I must export them over to YouTube because I don't want to lose the content. And I'm sharing it also with, the followers that are over there that actually watch the content, right? It's not everybody. But those that are watching, I appreciate you, okay? I do. Thank you for the support over there. So yeah, the series is over there. C++, I don't know, coding, lecture, class, something to that effect, playlist. It'll be easy to find. It's on the main channel. There'll be something there for you to find. It'll be quick. C++ series. Again, guys and gals, if you're just dropping by and this is a language you want to learn, I recommend you start and begin from the beginning, the beginnings of the beginnings. Because, I don't know. I mean, I just recommend go step by step, gradual, okay? Right? And that way you'll kind of understand my lingo and the coding lingo, and you'll be able to understand even what I'm saying for the most part. So yeah, that's what I recommend. Great to have you. And when you get to this video again, I'm going to be like, wow, hey, whoa, wow, man, you're back. You're still, whoa, what a beautiful grind. You got this far. That's amazing. Truly is. Getting this far, whoo, man, you're solid. Keep up the good work. Every single one of you, keep it up. Keep it up. Let's go, turn it up. All right, there. So that said, yes, Bologna and Wieners coding, right? We're trying to we're still pushing, still grinding, trying to get away from Bobliners and Bolognas. And yeah, hopefully one day, I always say beef Wellington, but I'll probably never eat beef Wellington. It'll probably just be like steak or shrimp or something, stuff that's, a little bit better than wieners and bolognas. The stuff that they scrape off the floor, guys. I'm just kidding, guys. All right, I don't mean to turn you off from the stuff. It's still good, though, isn't it? All right, enough of that. I do apologize. Nothing like a good old-fashioned barbecued wiener. But I guess helps if you actually own a barbecue. It's another thing I don't have. I guess I could put it in the exhaust pipe of my vehicle, heat it up that way and cook it. What do you guys think? Smoked wieners? Smoked exhaust pipe wieners? Oh, let's go. All right, turn it up. We're going to do this, guys. Time to learn. A little bit better mood, apparently, compared to the last video. I guess I kind of gave you an idea what it could be like. If it doesn't get any better, I'll continue doing those kind of videos. Anyways, yeah, wasn't that awesome? It was great. I changed my attitude, so a better mood today. I will give you that. So things should, be a lot better. It helps. I do have coffee. I got milk. I got sugar. Winning. That's a W. All right. Yeah. Flick the old switch in the cranium. It's time to put on the old thinking cap. Let's learn, guys and gals. Let's learn. Insert transition here. All right, we're into another section now. Okay, I was thinking of redoing the last stream, but I'm like, whatever. I'm going to post it anyways, right? I'm not going to please everybody. I've come to that reality. There's no pleasing everybody, no matter how much you try to kiss their. All right, let's go. Exploiting references. Ooh, exploiting. Man, okay. I wanted to go on a tangent, but I must resist. Okay. Last whatever stream, you learned how to use pointers and manipulate objects on the free store. So the last however many videos it was when we began the journey of pointers. Excuse me, guys and gals. All right. And how to refer to those objects indirectly. Okay, references, the topic of today's video, right? This stream or this lesson, give you almost all the power of pointers, but with a much easier syntax. And yeah, I kind of mentioned that in the beginning. It's probably, I don't know if it's the most common, but it's definitely the easiest one, right? All right, I'm going to keep my inside voice inside. All right, today you will learn what references are, how references differ from pointers, how to create references and use them, what the limitations of references are, how to pass values and objects into and out of functions by reference. Let's go. A lot of the content I've been doing, introduced you guys to passing by reference kind of right from the get-go. So majority of you that have been following the series, every single one of you winners, you know you are. You'll already know what's up, right? Because we're all playing golf together, right? Yeah, I can't wait. Hang out playing golf with you guys and gals. Play some golf cart bumper cars. It'll be a good day. It'll be a good day. I would like to do that. I would do that for real, for real. If I actually made money doing this kind of stuff. Oh, yeah. Good times. It would be a good time. My dream is to one day. What is a reference? Okay. A reference is an alias. Okay. That's what they're calling it. Okay, we'll just roll with it, you know? When you create a reference, you initialize it with the name of another object, the target. From that moment on, the reference acts as an alternative name for the target. And anything you do to the reference is really done to the target. Okay? We'll do examples here. It'll become clearer. You create a reference by writing the type of the target object. Okay, right? When you hear the word type, you just think, like it could be an int type, right? That's what types are called. All right, for example, an int would be a type. Followed by the reference operator, which is the ampersand, right? Do I have those notes here? Right here, yes. Okay. Right there. And then I got think memory address. I was just wondering if I should actually put like something like heap allocated, just so that it's clear. Okay, I'm just going to leave it like that for now, because we can still use this, technically speaking, just like for stack. All right, memory or allocation. Let's continue. References can have any legal... Did I finish that sign? Okay, hang on. Let me just continue where I was. So followed by the reference operator, the ampersand, followed by the name of the reference, followed by an equal sign, followed by the name of the target object. I better type something here just to clarify everything that was just said. I don't want you guys to be going, what? Okay, so this is kind of, to me, unique. I don't know if it's an old school thing. I don't want to call it old school. It is an older course outline we're following. Normally, we haven't actually declared this. That's why it's unknown. Some int. Okay. I imagine that's what they're kind of doing. I have to kind of figure this out. I'm analyzing this on the fly here. I should prepare better, to be honest. I do apologize if I'm not, guys and gals. That fixes it anyways. Let's continue. So, references can have any legal variable name, but some programmers prefer to prefix reference names with the letter R. Okay, that's fine. Thus, if you have an integer variable named SumInt, okay, that's what we've done, local variable, you can make a reference to that variable by writing the following. Okay, now what we've been already doing, so that you guys aren't getting confused, like we've been doing pointers, and we would create a pointer. Let's say it's pointing to some int, okay? And then we're going to make it equal to the address of some int. Okay? That's what we've been doing thus far. Okay? Just so you guys can kind of see the difference. This is what we did already in the past. Pointer, right? Create a pointer which holds a memory address. Okay, I don't want to go into that because we're kind of going backwards here. We're moving forwards. This is kind of a new-ish, like it's not really past. I look at this isn't really passing by reference to me. This is a bit unique and somewhat, actually, I won't lie, new to me. So let's see how it works. Again, it's not common for me. I don't normally write code this way, so. But again, it's just another tool in your coding tool chest. All right, guys and gals? Let's continue. So this statement is read as our some reference or some ref is a reference to an integer. Okay. A reference to an integer because, yeah, it is. This is still an int. This is still an integer, right? Nothing's changed here. The data type is an int. So, and there's no other syntax around it. So looking at it, you can go, yeah, it's just my variable name. That's all it is, right? It's equal to our variable. Okay, let's keep going. References differ from other variables that you can declare in that they must be initialized when they are declared. Okay, so what they're saying is you got to initialize it when you declare it. Okay, I imagine this is probably the way they do it. I'm not a fan of doing this newer stuff, to be honest, guys, but I'm just going to roll with the punches and do it anyways. All right, if you try to create a reference variable without assigning, you receive a compiler error. Okay? Yeah, you probably would, right? Compile time errors, right? Note that the reference operator and ampersand is the same symbol as the one we used for address operator. Okay, so this is okay, wow. All right, guys. Just got to organize it in our head, all right? Okay. So we have the passing by reference. If you go back to that video where I showed you the 3 examples, I think that's a really good video. Passing by value, then passing by reference, and passing by pointer reference, okay? Passing by value is kind of just the beginning stuff. We're just learning how to code, right? That's kind of really what passing by value is. It's just part of the learning curve, you know? So going from passing by value and kind of leveling up your coding skill set by doing passing by reference and passing by pointer reference. This is another thing that we're doing entirely, something new. Okay, it's not the same, and that's why I talk about it, because I want to be clear about it. Okay? Of course, I don't have the examples in front of me. Right? Passing by reference. This would be the syntax. Okay? I'll just do it again. Int p some int. Whoops, I'm missing syntax. Apologies, guys. Oh, yes, pointer. Maybe it's not. Okay, yeah, because we would make it equal to the memory address. So yeah, in a sense, it's the same. Okay, and then of course, some int. Just organizing in my head here and kind of wrapping my brain around it, okay? All right, so I'm going to put this maybe up here so it's separate from what we're doing now. Okay, and I'll comment it out because we're really not using it. Okay, this is a pointer equal to a memory address. That's what we did before. This is something kind of new, so I want to kind of like reset your thinking here a little bit so that we're not confusing the two. All right. Okay, note that the reference operator AND is the same symbol as the one we used for the address of operator, okay? And that's what we're seeing here, right? Did I write that? Address of operator, okay? Another thing they call it. All right. And that would be this here, okay? Right here. Let me do this. Okay, I'm just kind of slowing things down here so we don't get lost or confused, all right? Get some organization in our library up in our head, all right? Okay. These are not the same operators. Okay, there we go. However, although clearly they are related. Okay, so this is kind of what I want to be implicit about. I feel like I'm using the wrong words, but you get the idea, right? We're trying to separate the two concepts here, all right? That's the goal. This is a new concept. Demonstrating the use of references. And I realize we're using the same words. Okay, let's just write some code. Let's do that. Okay? Let's write some code. So they have, let's just go like this. Is it heap allocated? Let me look here. It doesn't, I don't see newing up. So, and there's no delete. I don't see delete going on or anything. So I'm going to assume stack allocation. They have an int called, it's kind of lame sauce, but I'm just going to leave it as some int, whatevs, okay? And then I'm going to go int ampersand. Do they have the ampersand with it? It looks like they do. Now, whether the program actually keeps it there, I don't know. Let's find out. Some ref. Okay, and it's going to equal to this. Right? Yeah, see, it moves it. You noticed how it moved it automatically? So again, just like pointer, it kind of associates itself with the data type. So it moved. All right. So there we go. We've done some declaring and initialization. Okay, that's all we've done. Nothing too special about it. So now we're actually going to give some int a value. Okay, because right now it's 0. All right. So we're going to give it a value. Okay, there we go. It has a value now. Went from 0 to 15 here on this line. Okay. Standard cout. And let's just see. Let's see what's up. Okay. You do enough coding, you can actually start learning and just deciphering other people's code, figuring it out if you do enough grinding. Again, you have to put in the time, guys, right? This is kind of like something you want. If you really desire to learn this, you got to have commitments. All right, every single one of us, and those that are learning as well with you, support you. Okay, they're there behind the scenes, cheering you on too. Every single one of you. Okay. Again, there's no harm taking a day or two off. Go for walks, nature walks, walk your dog, walk your cat, walk your turtle, do whatever you have to do. Clear your brain, enjoy some lifetime, all those good things. That was a little bit of a late laughter with the walk the turtle. So yeah, still funny though. What the? Who said? What? Unbelievable. I had to do that. A commercial tried creeping in. Just a bunch of betas, pretending that they're all nice people when they're actually just being fake to each other. Uh-oh. Oops, that was the wrong one. My bad. I meant to do this one. One more time. Go! Sorry guys. It was my inside voice coming out by accident again. I do apologize. All right, let's continue. Let's see. Okay, so on this line here, guys, all we're doing is printing out what the most current value of some int is. That's it. It's going to retrieve out of memory whatever the most recent or currently stored value in memory of some int. Okay, that's all this is doing. Nothing special about it. Okay, we're just printing it to this screen. Okay, let's see what the other thing does. That's kind of what we wanna. No, we're not counting. Let's see what the other one does. Okay. Oh, there's a before and after. Okay, good. I like this. So this is going to be before. I like the before and afters. Okay, so we're going to print. Is it going to return an integer? I'm curious. I guess it must. Because I think when I see the ampersand, my brain already thinks memory address. So it's like kind of the opposite. Right, this pointer here is a memory address holder, right? This is a memory address holder, so it can hold a memory address. We kind of change with this symbol. We're changing it from an int to becoming. I want to display a memory address. Okay, I'm trying to just explain it in the most simplest terms I can, guys. Okay, that's what this is doing, right? So it's a left-hand, right-hand side thing, kind of like the teeter-totter balancing scale. If you're going to compare an int to an int, you have to, both sides have to, on each side of the equal sign, have to be int. Make sense? So this is a memory address in the sense. This here is like kind of breaking my brain a little bit because I look at it and I look at it and I go, ampersand, well, that's memory address. And that's kind of what I've been teaching you guys and gals as well, right? So, yeah, I can see why people kind of get thrown off from this language, right? Again, don't let that discourage you, right? If you're strong and you want to persevere, you'll keep going, right? And not give up. Just like I say in chat, right? Let me just see here. What do I say in chat? Did I paste it? I thought I caught. When they say it's impossible for them, not for you. Let's go. Okay? All right, so keep going, keep trooping and trudging on and persevere. You can do this. You can do this. All right, so you just got to kind of, organize it and save it, store it in your mind. You could use mnemonic devices, however, whatever techniques you use to help retain information or knowledge. Okay, I understand because I finished college, so I know what it's like to study and grind. I put in the time. All right. Okay, so I have to finish this. I'm not quite done. So yeah, it's like I'm looking at it going, well, how are you printing an integer when you look like you're a memory address, right? Let's find out. Let's see what it does. Curious. So in here, what they're doing now is they're taking, it's interesting, very interesting. We can actually, guys, this is wild sauce. With this, now you gotta notice the placement of the syntax. That's why I'm always like kind of saying this a lot, guys. The position where you put certain syntax, like the ampersand or the asterisk, it has its own. It serves a certain purpose or function, depending on the placement in your code. Okay, so that's where you have to organize it in your head, right? Oh, I have an ampersand here. It's doing this at this moment. That makes sense? Okay, so looking at this is still an int comparison. Left-hand side int, right-hand side int. I guess you just got to tell your mind, I don't know. I'm going to read the breakdown here and then hopefully it gives us a good explanation. So what should I make it? I don't know. Let's make it 23. Okay. So we're going to print a before. Let's go like this. A for after. I'll go aft. Just so you guys can see. Aft. I didn't want to use the colon again. And then, it's going to kind of look funny, but BEF for before, okay? So you can see it in code, okay? So if we look at it, right? Okay, let's look at the first lines, right? Code is run line by line until it reaches a function and yada, 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 right? So line by line, it's going to take in this information. Some int's going to be a 0 here. Int, what do they call it anyways? They call it an alias, okay? In this case, it's an alias, okay? Now, I know I said a reference is an alias before, so this would be, we could call this, the way we're doing this, an alias, I guess. However you want to remember it. I don't want to call it passing by an alias, right? Because that really doesn't make sense. Something to remember this. Okay, we're doing an alias here. Okay. All right. I would assume, right? And that's kind of how I'm going to remember this. Just another tool in your coding tool chest. All right, guys? Okay, so that means that this here must equal, obviously we can see it in code, it's equal to some int. So it should equal 0 here, right? It should. Oh, I better comment this out because that's not part of the code. Okay, and because this is passing by reference, okay? Pointer reference, whatever, however you want to look at it. Okay, we're using a pointer, and this is, in fact, a reference. You notice the ampersand's on the right-hand side of the equal sign, right? This is what I'm talking about, position. Here, it's on the left-hand side. Changes the game a bit, all right? Take note of that. All right, so and then line by line, so now we're actually initializing some int to the value of 15. So we should see, right, because there's really no change going on, we should see 15, then 15 here. Okay, what's going to happen here? This is the part where we have to figure it out. It should still be 15 here because we're not really changing it. But what's going to happen on this line? Does it change it? Does it? Oh, thinking about this, I'm going to stop. I haven't run this before, guys. This is my first time running this. I'm thinking, this is what I'm thinking. It's going to change the value of some int. So that must mean, my guess is that this is going to be 23 and this is going to be 23. Let's check it out. Let's see if I actually know what I'm doing. Let's go! Let's go! Let's go! Let's go! Oh, that's the wrong one. Turn it up! Turn up your turnips, boys and girls. Turn up your turnips. Turn up your turnips. And again, I figured that out without any, pre-studying, pre-doing whatever, pre-researching, pre-line code writing. This is all new to me. This is new to me. It's new to me. Okay. Okay, commercials. You want to eat donuts? Oh, yay, good for you. You could do soap commercials. I'm so impressed. I'm glad you get to eat steaks. Get out of here. God. Take your soap commercial and eat some donuts. I'm saying that in a nice way. Okay. Just add another level of intelligence, and I'm country. All right, let's go. Let's go. That's pretty awesome. So I was thinking of doing this just to create some separation. Again, figure things out without chat GPT, without having to phone my cousin, and I figured it out. That's pretty awesome. I like it. I like it. So now I understood that because I know with pointers, if you change the value of a pointer, you have to dereference it to do it. It's the same kind of analogy. The same things are happening. It's just done in a different way or fashion. Okay? So cool. I love it. Just another tool in the line coding tool chest. And you know what? That might even be easier because really when you do it the other way, right? So here, I could actually I can change the value of this through code as well, but I would have to dereference it is what I mean, right? So again, it's all about what's this symbol doing at this particular moment of time. Okay, so I could print some int, right, and also affect the value of some int by dereferencing. Okay, I'll build this. I shouldn't have any errors in code. Okay, good. All right. So let me find out. Let's do this. So I'm going to go like this. I'm just going to comment this out. I'm going to take this and show you. Okay. A lot of people might use this method here because really it's only one symbol, guys. But if you understand what this is doing here, it shouldn't be a problem as well. Okay. So now I'm going to have a before after again. Except I guess I should have did this. I'll be a little bit lazy here. I was just trying to avoid having to do that. But I'm printing this instead. Okay, I commented this out. Okay, this is still all going to be normal. It's going to be 15, whatever. Okay, I don't even need to print that out. It doesn't matter. Okay, but I want to show you this, and I want to show you the value of some int as well. Okay, and I believe I have to do that. Yeah, because it's a pointer. All right. All right, check it out. All right, let's go. Okay, boom, 34. Okay, guys? Boom. Let me yays. So, if you've been following along and you are a beautiful, intelligent individual, right, learning along with Johnny here on Bologna&Weiners coding, you're amazing, right? So it's just another way of doing things. You can see we affected the value of some int by using pointer reference, right? In a sense, because we are using a pointer, so it is still passing by pointer reference. That's kind of what I call it. Okay, I've already showed you this method in prior videos. And if you're learning, when we originally learned, or when I showed you guys passing by reference, it's pretty easy, right? Pass by reference, we're only using one symbol. I think it gets confusing for people when you have to add in the extra symbol, right? The only thing you just have to remember what it's doing. Here, we're creating a pointer. Here, it's a memory address. This is storing the address. We have to dereference it so it's actual integer value. That's what this is doing. We're converting it. I guess I could call it converting whatever's happening under the hood. We're changing the output from a memory to a value, right? I can't make it equal to 34 if it's a memory address. 34, a memory address is not equal to 34, right? Makes sense? It's the logic of understanding what's happening on the left-hand side, what's happening on the right-hand side. What's this symbol doing here? What's its function, right? And again, I have to add it here. Maybe that's why people find it hard, because they have to add in another symbol. Oh my God, go back to Python or Lua. And there you have it, boys and girls. There goes another follower. It's okay. It doesn't bother me. I don't want them around anyways. If they can't get through this, they should, I don't know, McDonald's something, I guess, because it's obviously not for them. All right, I'm gonna shut yaddy. I do apologize. Again, if it's not for them, okay, that's saying again. I'll say it again. When they say it's impossible for them, not for you. Let's go. Losers quit when they fail. Winners fail until they succeed. Let's go. Turn that up. And every single one of you that's still part of the channel and watching the content, every single one of you winners, you know you are. Okay? I don't want the quitters or losers coming back anyways. Okay? I don't want them. Don't come back, quitter. I don't want you back. Okay? All right. Let's continue and keep going. Oh, I'm getting killed with commercials today. Okay. Ritz Crackers, you owe me $1,000 for your 3 seconds of commercial. Okay? I want $1,000. All right? Okay? I'm doing a live stream here. You're forcing your commercial into my live stream video. Okay? Trying to steal from my pocket. Okay? You owe me $1,000. All right? God. Let's go. So a breakdown of what they're kind of describing. Okay, create a local integer. That's fine. A reference to an integer on is that what they're calling it? A reference to an integer. We could call it by passing by alias. I don't know. Do you guys like that? Could be a way of looking at it, right? Oh, I'm gonna remove all this. Okay, I'm gonna go like this and like this, and then I'm gonna comment that out and call it passing by bay. Yeah, I would like to hang out at the bay. Passing by alias. What do you think? Huh? What do you think? What do you guys think? I like it, kind of. Right? And again, it is pretty easy. You can still get you the same work done without having to use pointer, and then without having to create a pointer, and then making it equal to a memory address, and then of course in code here you still have to dereference it, right? Using the dereference or indirection operator. That's what I call passing by pointer reference. Okay, guys, to be clear. I should have fixed that. Sorry, guys. There we go. Okay. That would be the second one, I guess. And this would be the third one. Passing by alias. I'm excluding passing by value because passing by value is something you don't really want to do. Okay, if you actually want to be serious and create programs and applications, again, C++ is the main language. All the other ones are just posers. Okay, they're the ones that are like just following, trying to compete with C++. Again, I love C#. I'm not going to say anything bad. And C language is the OG language, so I'm not going to say anything bad about that either. Without C, there wouldn't be C++, right? So that's the OG C language. All the C coders, they're all legends, every single one of them. Okay, so yeah, passing by value, that's just beginner stuff, right? You want to move away from passing by value, all right, guys? Just throwing that out there. I was reading their stuff here. So they're calling it, I called it passing by an alias. Okay. And is declared and initialized to, right? So it's equal to an actual integer, right? If you declare, you get the idea. I don't think I need to read this, right? I think you guys are intelligent. You get the idea. I feel like sometimes I need to just shut up because I feel like I'm just over explaining, right? But I want to be clear. I want to make sure you guys understand as well. The using the address of operator. Okay, the code kind of looks similar. All right, there's still, I want to kind of help you guys organize this in your mind, how to remember what is what, right? They're doing a lot here. To me, when they say using the address of operator, I think passing by pointer reference. Okay, or even passing by reference, by all means. Because passing by reference, well, that's all through functions, right? And I'm not showing you guys through functions, so that kind of I don't want to say confusing, right? Confuses you. We're kind of doing all the code here in the main. We're not passing anything into functions. We're just showing examples and spitting out output in the console. That's all we're doing here, right? Normally this stuff is like, when you're doing these sort of things, you're like passing into a function or a method or something, right? Okay. You have now seen that the AND symbol is used for both the address of a variable and to declare a reference, okay? But what if you take the address of a reference variable? Oh man, you guys need to stop. If you ask a reference for its address, it returns the address of its target. Well, yeah, we can print an address. We've done that, guys, right? That sounds like what they, sounds like that's what they're saying. This is the nature of references. They are aliases for the target, okay? I guess you're not really passing by an alias. We're not really passing into a function, so me calling it passing by an alias, yeah. All right, so their outline says that is the nature of references. They are aliases for the target. Some int is the target, okay? This is an alias for a target. All right? So this example demonstrates taking the address of a reference variable called rsumref, okay, which we've done here. Int and alias equals an integer. It makes sense. It's an alias, right? That's why I'm like, well, man, you guys, what are you doing? We already looked at this and we were like, we stored it in our minds as a memory address. Now you're doing something entirely different with it, right? I'm not letting it confuse me. I just try to organize it in my mind to help me, remember things. It's all part of the learning process. So look at it like an alias. It's equal to an integer without over confusing it in your head. Okay? So we did this, and then we're just kind of printing it out. And okay, let's see what happens here. Okay, so I'm going to get rid of this. So when we did this, it's going to go, I got to change this. No. Oh yeah, that's fine. Okay, yeah, that's fine. Okay, I'm just going to print what we had before. Okay, and then I'm going to show you something else. Okay, we should see 2323 right here. Okay, boom, and that's what we do. Okay, all right. Now, again, that's using an alias, right? So now with their code, they're showing this. Okay, I'm going to get rid of this. Okay. I just got rid of that, okay? I'll even just uncomment. I'll just comment it out, okay? All right, so now we're not changing. We're not affecting this, okay? That's what this is doing. It changes this up here, right? All right, so if I print it, we should get the same output with before and after, right? So watch, same output, okay? No change. All right, I'm just duplicating the printing. That's all I'm doing. Now watch this. So they're going to use the ampersand, okay? I was thinking of doing this instead of calling it that. It's up to you how you guys want to remember it. Aliases for the target. Okay? Aliases for the target. Because I don't want to really call it passing by an alias, because when I say passing, usually you're passing into a method or a function, right? Here we're just changing things in main, displaying them. Okay? So, int 1. Okay, hold up. We're gonna okay, let's go like this. They're adding in the ampersand, but am I changing? Yeah, okay. All right. And then we're adding in the ampersand. Okay, what's happening here? All right. So, with what I read earlier, this is kind of a new section, guys. All right. And it's called using the address of operator on references. Okay, that's what it's called. Just to be clear. Okay? Using the address of operator on references. Okay? And okay, yeah, busy. And that's what we're doing here. Okay? To me, this is going to be printing the memory address. If I look at this, that's what I'm thinking is going to happen here. Okay, let's find out. Oh, it is too. Let's go. So that's exactly it too. Makes sense, right? As you can see, they're both exactly the same. Now, if you guys and gals do this at home on your own computer, whatever you're using, this hexadecimal is going to be different. Okay, my RAM is not your RAM, and your RAM is your RAM. So, right? Make sense? Okay, it's going to be different. If you see hexadecimal format, you're fine. You're doing good. All right. There's my kid knocking, telling me he's getting his lazy donkey behind up. Just waking up. Teenagers. All right. I'm always up in the mornings. So, I don't wake up at 3 o'clock and start videos, guys. Unbelievable. Okay. I can't live like that. What a waste of a life. Okay, teenager life, that's fine. I mean, that's what teenagers do. I know I did. But when you become an adult, if you're sleeping till 3, you're wasting your life. All right. Unless, of course, you've been coding and grinding code all night. That's okay, too. Okay, guys? All right, so that's what you get. And I had a feeling, because here I knew for sure this was going to print a memory address. But I was kind of not 100% sure what this was going to do. But that makes sense. Okay? So we use the call, what do they call it? Using the address of operator on references. Okay? Again, this is an integer. It's holding an integer value. It has to be, right? That's what we're printing out. If you're printing an integer, obviously, you know. Anyways, okay? Again, it's an alias without over-explaining it. Because the final 2 lines print memory addresses, that might be unique to your computer or to a specific, yeah, right? I gotta kind of be clear about that. Some people might not know that, right? Okay. We print, so again, this is nothing new, guys. This is just what you do if you want to print out a memory address, right? By using the ampersand operator, okay? Or address of. That's nothing new. Okay? What we did here is, though, okay, that's new. I'm calling it 3 because number 1 was passing by reference, and it might not be the same. I could call it 4, right? Passing by value, which you don't want to do, right? That's why I was kind of excluding it, guys. Number 2. And number 3 would be passing by pointer reference. Okay, as a matter of fact, I don't even need to do that. I could just go 3 here. Right, I was just excluding 1. That's all I was doing. That's why I called it 3. Okay? So you can clearly see, right? I'm just going to cut this out and move it up here. All right? Just different ways to do different things with either similar outputs or different outputs, okay? Organize it in your mind, right? I believe in you. C++ gives you no way to access the address of the reference itself because it is not meaningful as it would be if you were using a pointer or other variable. Again, you got to just think of it kind of like a pointer, right? It printed the same address because we're kind of linking them together, right? It has its own memory address, but it's linking. It's holding that information, but it still has its own location in memory without over-explaining it, right? It's a different person, right? Think of it this way. This is a person. This is a person. They're standing in memory. It has its own location or address in memory. It's got a piece of paper in its hand and it's holding the address of this guy, right? However you want to look at it. Okay, I could hold a piece of paper with somebody else's address in my hand, can I not? Right? Let's go. All right. The references are initialized when created, and they always act as a synonym. You guys want some synonym? Synonym. For their target, even when the address of operator is applied. All right, I think we should move forward. How are we doing for time? Still doing okay. Normally when you use a reference, you do not use the address of operator. You simply use the reference as you would use the target variable, okay? All right, attempting to reassign references, not, and then they got an exclamation point. Okay, let's see what this is, what's up here. Normally, you know, like I would just kind of show and share to you guys the stuff that I do and know, but I'm following this course outline, so, they may use this type of code in companies and such, guys, right? So you do need to know about this stuff, right? If you're at home, you might not use this sort of thing, right? Just leveling up here, guys. And it doesn't hurt to know about it. Whether you use it or not is another thing. Okay? Be careful to distinguish. That's kind of what I was doing here, right? Helping you guys distinguish. Okay? All right, let's continue. Reference, we're on the attempting thing now, okay? Attempting to reassign references. Reference variables cannot be reassigned. Okay, so store that in the old memory banks. Reference variables cannot be reassigned. Even experienced C++ programmers can be confused by what happens when you try to reassign a reference. It doesn't really make sense why I would want to do that anyways. Sounds kind of like you're getting to the point of breaking your program. All right, reference variables are always aliases for their targets. Okay? Pretend that they're not real, they're fake. Kind of like the blue rules. What appears to be reassignment turns out to be the assignment of a new value to the target. Okay, so they're using the same. Okay, so int da. Okay, this is all unchanged. What are they doing in here in code? I have to clean this up, guys. Okay, I'm cleaning this up. And let's go over their example. So, same thing. Equals, I don't know, 43. Okay, just change it up a little bit. Standard cout. And we're going to print the value of some int, right? It's unchanged. Well, it is changed. We changed it. Initially it's 0. On this line, we're changing it to 43. It gets stored under the hood, right, guys? Container, memory, all that good stuff. Okay, so all we're doing is printing. Here we're going to be printing the value of 43. That's all we're doing. Nothing special. Now let's print our sum ref. Okay. At this point, it should equal to whatever this is, right? Right here, it's 0. It's going to be, because this is 0, this should be 0. Okay. But then we changed it here too, right? So let's see what happens. Remember, it's equal to some int, so it should affect the value of our sum ref, right? Make sense? You have to kind of think like a computer a little bit, line by line. Okay. So if I print this, they should both be 43. Let's find out. We'll just kind of do this a little bit. And it is. Okay, and I need some space and stuff. Let me do this and this. Okay, there we go. That's just me doing typo stuff. So there we go. Big yays on that. All right, so that you guys understand, right? Okay, we changed some int, which also changes the value that are, again, it's an alias. So we're changing that value, whatever, I don't want to call it pointing to, however it works under the hood, I don't know. Okay, but the main take here is that the sum int variable actually changes the value of our sum ref as well, right? So just be aware. Okay, that's the take. And now we're going to ampersand this stuff. So when you see ampersand, think memory address. So all we're doing now, I don't know why I would do this. I just go like this. We're going to put an ampersand. We're going to put an ampersand. Okay, ampersand equals memory address, right? Okay, boom, boom. So both memory addresses should be identical because, well, one side equals the other side. Left-hand side equals right-hand side. Okay, and in fact it is. Okay, they're exactly the same. All right. I'm a slow mod here, guys. All right, let's continue. Okay, so nothing really different there, right? So this would be the before. Let's do some, there. Okay, so I'm just gonna go like this, and we're just declaring a new variable in code. It's gonna be called 2, and it's gonna be equal to, I don't know, 18, okay? Just a new variable. This is what this is, guys. We're declaring a new variable and initializing it to the value of 18, okay? And now we're going to create, okay, now we're going to make, all right, so be careful of this, guys. So we're going to take this reference, this alias, and make it equal to this, okay? So what did this say earlier? Earlier it said reference variables cannot be reassigned. Okay, that's what this is. I see this, and man, that looks like it's being reassigned to me. Okay, because it is a reference, right? Is it not? Is that what they mean? Is that what they're talking about? I don't know. Let's find out. Did we get a break in code? Yeah, so they got this. I'm already kind of thinking about this, thinking this doesn't seem like it's good. All right. Let's see. Do we get any compile or anything? Nothing right now. It's not even complaining. But our output, what's our output going to be? What's this? Int 1. Okay, so let's print out some int. This is the after. Okay, I'm just going to go aft. We don't need to do it for the other ones because we know that's before. All right. Right, I do need to do that. I'm going to go like this, and I'm just going to go like this and like that. Creating a double enter is all I'm doing. All right. Okay. So, okay, yeah, RNEK, yeah. Following along, okay. And now let's print out int 2. Let's print out some int 2 and see what happens. And let's print out some reference as well. Oh my goodness. Okay. What did I do, man? God. Copy and paste is bad. You really got to be careful. Okay, there. What? Oh, God. As soon as I do something weird. So annoying. Pissing me off. God. Like, I really have to be careful how I press and click buttons now. It's frustrating. Okay. Are you gonna work? All right, I'm fine, guys. Just shh, like this pisses me off. Okay. Back to what we're doing. It's kind of like 2 steps forward, 1 step back. Okay, printing some int 2 and printing some ref. Okay, and then of course we could print the memory address after, but let's just see what's up. All right, so looking at this, sum int, the original value of sum int should be 43. Because we're not changing it, I don't think. But then what are we doing here, right? Does sum ref affect the value of sum int? Previously, we proved and showed through code that it can. Okay. Here it's 18. Originally it's 43. Let's see what happens. Okay, 18, 18, 18. Every single one of them. So they all were affected. Okay, so now sum int is no longer 43. This is just printing the memory address, guys. That's all it is. And just to show that they're kind of, one's an alias, right? It's not the act. It still has its own memory address, I would assume, right? It's just printing whatever it's holding on a piece of paper in its hand, if you want to look at it like that. Whoa. Okay. And then let's print the memory address. And I'm just going to do that. Create a couple of enters. And they're printing int 1, int 2. Let's find out what... I'm going to go like this. Well, I guess it don't matter. All right. And memory address of sum int 2. Okay. Okay, you got to double click to get it to highlight. If you single click, if you notice, it's just the cursor's flashing in the middle. It'll paste whatever you're pasting in between, right? If you notice, that happens to me sometimes. It's annoying too. All right, let's go and run. Now, are the memory addresses going to be same all the way throughout? I don't know. They are, right? And they did change. If you kind of go back, click back, we have no control of where the compiler or the CPU, like the CPU is the librarian. It makes the decision where it's going to put this stuff in our RAM, okay? The RAM being our library, right, guys? Our temporary library. So it may change, but you can see it is consistent. No, it's not. Aha, look. Sum int 2 has a different memory address. It almost caught me there. It almost looked the same, but sum int 2, the memory address is different. It's almost like, yeah, it's printing its own memory address. Well, stop. Let me stop. R sum equals sum. Sum int, right? That's proof right there, right? Like I said, I've been saying all this time. Sum int 2 has its own memory address, guys. Okay? We made ref sum equal to sum int 2 here, right? We did. Yes, we did. It's printing the value, but here, wow, that's crazy. Okay, this is sum int 2. Hold up. Okay, printing memory address. Oh yeah, I need to stop. I'm overthinking. Right here, we are actually printing the memory address of sum int 2. That's what we're doing here. Okay, some int 2 does in fact have its own memory address. I didn't need to go any further than that, right? That is the memory address of some int 2. It's obvious, it says it right there, but to help you guys understand, right? Some int 2 has its own memory address. You know, right here, right? It's going to have its own memory address, but it can hold the memory address of this. That makes sense? It's like no different than some other person giving me their home address on a piece of paper. I could still hold that. I'll have my own address, but I could still hold somebody else's address, right? That help? I hope so. Okay. All right, let's drop the A's. How are we doing for time? Pretty good. Maybe I should cut it short so I let you guys and gals kind of absorb all this. And then we'll get on to next stream is going to be fun, guys. We're going to create a class. We're going to get back to doing the simple cat class. And this is where we're going to take all the referencing and such and utilize it in a class, right? Here, we're just showing the differences and printing out results, and we're just kind of seeing what it does, right? It's all part of the learning. That's all we're doing here. Just showing, right? Now let's learn how to use it with our classes, okay? All right. We're going to do that. That's going to be the next video. So I'm going to continue. I'll just finish reading here. There's a little bit more to do, and then we'll be kind of finished. And then next live stream is going to be called Referencing Objects. Something to that effect. All right? When you hear the word object, think class. Objects make the magic happen. I love working with classes. I do. They're fun. Creating methods and setters and getters. And oh man, it's all nothing but goodness. I love making the magic happen. Okay, I'm trying to read I would like to read their breakdown, but their line numbers are different to mine, so I'd have to scroll up and down, scroll up and down, scroll up and down. Let's see, on lines 8 and 9, okay, which is like, so that you guys can see, so they're talking about these lines. They're saying an integer variable and a reference to an integer are declared. Okay, there we go. A reference to an integer. Well, that's another way. That might even be an easier way to remember it, right? Or reference to an integer. Haha, that actually, I like that. I like that. Probably a little bit better. Whatever you guys and gals want to do, like this is a new concept here, right? Number 4. However, whatever you want to do to remember it, right? Because you could choose to do step 3, or you could choose to do step 2, or you could choose to do step 4. You're not doing all of it, right? It's like, well, I guess you could, but realistically, you're really only going to be doing either you're going to be in your code, in your own code, you're going to go use step 4, you're going to do stuff by aliases, or you're going to do stuff by pointer reference, or you're going to be doing things by reference. Just depends, I guess, what you're doing with your classes, with your methods. Do you have local variables in your main? Do you have global variables in your main? Are you passing by reference? You know, it just depends on the situation or circumstances in your code, right? Again, these are the tools. Use the right tool from your line coding toolbox and utilize it, right? Use the right tool. It serves a purpose in its right place or application. Okay, guys and gals? All right, the integer is assigned on this line here. Okay, yeah, that's fine. And the values and their addresses are printed. Okay, which is all here, right? That's kind of what we did. Yep. On this line here, I'm going up and down for you guys here now. A new variable int2 is created and initialized with the value 18. And then on the next line, right here, or this line, which is kind of crazy, that this says reference variables cannot be reassigned. Okay, I don't know how to ignore that or whatever. Kind of seems like an oxymoron, but anyways, I don't know. I'm not sure, guys. I'm not sure. I just threw that in there for you. Okay, that's what they said at the beginning here. All right. Don't kill the messenger. The messenger is just the messenger. Okay. Where was I here? The programmer tries to reassign rsum reference to now be an alias to the variable sumInt2. And that's true. But that is not what happens. Okay? What actually happens is that rsumRef continues to act as an alias for int1. Okay? Right? Yeah. That's what I would see. So this assignment is equivalent to the following. int1 equal to int2. So what they're saying is this is essentially what we're doing here. Oh God. Right? Oh God. Okay? Same thing. All right? That's what they're saying. Essentially, right? Because they're still linked here, right? They're still linked right here. Okay? So in a nutshell, they're saying, well, just so you guys understand, that's why I thought it was imperative I read this breakdown, right? The other stuff I can explain, but this stuff, we got to be fully clear to understand, all right? So what actually happens is that rsumRef continues to act as an alias for int1. Okay. True. In fact, when the addresses are printed, okay, hold up, I skipped ahead here, my bad. Apologies, guys. What actually happens is that rsumRef continues to act as an alias for int1. So this assignment is equivalent to basically saying sumInt is equal to sumInt2, or vice versa. Actually, it is vice versa, right? Which would make sense because it's the left-hand side that equals the right-hand side. Okay? Sure, well, they have it the opposite, but whatever. Okay? Sure enough, when the value of int1 and rsumRef are printed, which is right here, okay? Now I scroll up and down, I gotta find my spot here again. They are the same as int2. Okay, they are the same as int2. Okay, which is what happens. Yeah, we do see that. They are. Okay, so let's carry on for clarity reasons. In fact, when the addresses are printed on here, you see that rsumref continues to refer to int1 and not int2. Which is true, right? Because they're the same. Okay, so this is just clarification that with what they said earlier. Let me find that statement again. Yeah, that's the statement. What actually happens is that rsumref continues to act as an alias for int1, right? That's just proof right there that rsumref still continues to act as an alias for some int. Well, I changed it. They called it int1, int2, but it doesn't matter. Okay, variable is a variable. We are the creators and the the gatekeepers of the variable names, if you want to look at it that way. Okay, so that's proof that rsumref still continues to act as an alias for some int1. Okay, so here we go. Do's and don'ts, and then we're going to be finished. Do use references to create an alias to an object. Is this what they're using it for? I guess an object. I look at these as variables. I don't look at them as objects. Do initialize all references. Okay, so what they mean by that is right here, right? You have to initialize it. Okay? By making it equal to some int, that is initializing. All right? Don't do this. So don't try to reassign a reference. And in a sense, that's what this means here, right? That's why they're showing all this. Okay? That's why they're showing all this, guys and gals. Right? Just to prove that you shouldn't be doing that, because if you're not aware, if you're thinking that you're changing, it's not like you're using passing by pointer reference. It's not the same, right? So the reason they're explaining this is, let's say you have a big program and you've done this and you're trying to figure out the bug in your code and you can't figure it out. Well, right here, that should be the bells and whistles. Okay, that's the bells and whistles right there. Don't confuse the address of operator with the reference operator. Okay? All right, here we're using the address of. Here we are using a reference to an integer. Okay? This is a reference. This is an alias of. Okay, I think you guys will be fine as long as you realize this is just another step, right? Something different. Just pay attention to the position and the syntax. If you notice, the address of is on the right-hand side of the equal sign, okay? But it's on this side of the variable, okay? With alias for the target or reference to an integer, it's on the left-hand side of the equal sign, okay? So, for memory's sake, that should be easy enough to recall. All right, guys? Apologies for the last video. Again, I'll get like that again if I don't see the views up. Okay? Guy kind of gets to a point, it's like, why even bother? Anyways, but for you guys, the ones that are actually watching, you guys keep me going. Much love. I'm going to leave it at that. Johnny with Bologna&Weiners coding. Much love. I appreciate you again. Next stream that we do is going to be, we're going to create a class. All right, so stay tuned. Again, we're going to be going back to the cat class, and then we're going to be working with referencing objects. Turn it up. Are you excited? Yes, we are. All right, much love, guys, gals, whoever you are, wherever you are. Have an awesome rest of your day, evening, noon, and night, or nights. Take care for now, and I'll see you in the next live stream, or not live stream. Let's go. And peace.